talk about your normal distribution. Now, I gave you the properties in your notes as well as on a separate sheet. This is really, really important that you kind of get this part. Here's your normal curve. And I think I drew a normal curve there for you. Your normal curve is your mean, your median, and your mode are in the middle. This is mean, median, mode, middle. Everything's in N. Okay. The normal curve is bell-shaped, perfectly bell-shaped, and symmetric about the middle. The total area under this curve, the total area, is equal to 1. Okay. The normal curve approaches the axis, but never, never touches it. We make it look like it does. Just like, remember when we were talking standard deviations before? Your normal curve is more like this. It has more like, comes out like that along. But if our plus or minus 2 is there and our plus or minus 3 is there, we have no place to write. So again, we kind of exaggerate the curve when we draw it. It's kind of like sketching. If you took pre-calc and you sketch something, in pre-calc, we don't use your calculator as much. We sketch everything. If we sketch a log curve, we just sketch. And we talk about the sketch of it. We don't exactly find the fine points. So, again, we're kind of expanding our curve, even though a plus or minus 2 and 3 are very, very close in here. We would have nowhere to see the percentages. So we kind of expand this. This does go on and on and on to your x-axis, but never, 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 never touch it. They also say between the plus 1 and the minus 1, it's called an inflection point, where it started to turn down, then it decided to turn up. If you took pre-calc or calculus, you probably looked at inflection points. We don't really do anything with inflection points in statistics. We just know that the curve is such because if it's really your plus 1 and your minus 1 are probably over here somewhere. No, closer down there. Again, most of your data sits here. Your data is unusual if it's less than 5%. It has basic properties. Now, how we find these things are, your total area is 1. These guys are your negatives, these guys are your positives, your standard deviations. And we call them your z-scores. And we looked at z-scores in chapter 2, right before we did your probabilities. We're about to bring back your z-scores, combine it with your probabilities, and talk area under the curve. That's where we're going with this. You can have any mean, and your standard deviation is always a positive standard deviation because it's a distance away from the mean. And we'll see how spread out your curve is based on your standard deviation. So, this is your normal curve. This basically is your normal curve. So if you look at example 1 in your book, one of these is example 1. It just got moved somehow. It looks like this one is example 1. I don't know if I can move it. Okay. So if we look at example 1, whoops. So where it went, somewhere over here. Okay. It says, right? Is that what you have? It says which curve has a greater standard deviation. I'm on page 235. Bless you. I'm on page 235. Remember what we talked about standard deviation? If the curve is more spread out, it has a greater standard deviation, right? It's further away from the mean. So which curve? Curve A is the red, curve B is the blue. Has a greater standard deviation. B. Okay. This is closer to the mean. Standard deviation is closer to the mean. They're both bell-shaped, but they're closer to the mean. Okay. So the same thing with this one. Which one would you say, A, B, or C, has the greatest standard deviation? C. Which one has the least, the smallest standard deviation? A. They're all normal curves, but they can be different shapes depending on where your standard deviation is. Okay, so just so that you get a good feel for that. Some of these are kind of useless to go through because you know a lot of these already. I'm going to pass over this. This is kind of useless. All right, now we get to business. We use your standard normal curve. Your standard normal curve has everything that your normal distribution does, and it has a little bit more. It has a mean of 0, and it has a standard deviation of 1, right? Then we're back to your favorite little z-score formula. So this is your z-score formula. It says this. This is where your 0 is. Standard deviation of 1. It says this. It's got a few little things that we have to remember. And you remember this when you look at your table. I'm sure you'll remember this. It says, as your z-score gets closer to negative 3.49, okay, the area accumulated, and our area is always accumulated to the left. Make yourself a little note of this. The area to the left basically is 0. If you look at your table, I gave you your table 4, negative 3.49 is your last entry on that table. Anything to the left, we're going to say virtually 0. Therefore, anything to the right of this number, anything to the right, we're going to say virtually 0. Therefore, anything to the left of this number is 100%. So if you pick up your table for a second, I want you to tie all this in together. And you look at positive 3.49, go to the positive side, go all the way over to the right. It says 0.9998. Essentially, it's all this area to the left. It's almost 100%. If I move this decimal, it's 99.98% for the area. That's just your regular table. Did you get one, David? Same thing if you look at your negative. Look at negative 3.49. That's your first entry on your table. That's essentially 0. There's very, very little space to the end. So they consider this essentially 0. Okay, that's as far as your table is going to cut this off. It says that z in the middle, halfway through, a z-score of 0, covers 50% of your curve, doesn't it? 50%? And the other half is 50%. And it says the cumulative area is close to 1. We just talked about that. 100% or 1. If you look at your chart, everything's in decimals. We leave them in decimals unless it specifically says percent. If it specifically says percent, then you're going to take your area and just move your decimal 2 places to the right. Okay? Once we get rolling with this, you'll kind of see what we're talking about. All right. Now, what I want you to remember is, on this table 2, do you see this picture at the very top of your table? Where is it shaded? To the left of the marker or to the right of the marker? To the left. That means you're measuring area to the left. If you wanted the area to the right of this marker, what do you think you would do? You would shade it to the right, and how would I find that area? Anything left from 1, right? If your whole area adds up to 1, if you want the area to the right, then we're going to use 1 minus that area. It's like the complement condition. Anything but, everything but, just like Will said. Anything but that. So if I'm looking for this guy, I want to find the corresponding area, the area that corresponds to 1.15. Here's my 1, here's my 2. 1.15 probably falls in here somewhere. Here's my standard deviation. I want the area to the left. We looked things up on your table already. I did it ahead of them in chapter 2 because I said you were going to need to do this. Now, just by looking at this graph, just by looking at it, should it be more than 50% or less than 50%? More, right? It covers more than half of it. So go to your table. You're going to find 1.1. You're going to come across the top to 0.05. This is where your hundredths is. This is your tenths. This is your hundredths. You're going to pull out that area for me. So what is that area? .8749, right? Everybody got that? Okay. Now, using the rules that this whole area, excuse me, adds up to 1, if I wanted to find this area right here, I would do what? I would subtract. Because this can't possibly be 87%. It's too small, right? I would subtract it from 1. Because one of your characteristics of this curve is the total area is 1. Okay, now, here's another little characteristic here. You gotta watch real closely. Okay, now, say I took negative 1.15, and I wanted that area to the left. Let me subtract this area first over here. As a matter of fact, look up negative 1.15. Do you get this? 1, 2, 5, 1. So, I notice that when I look this up in my table, I get the same thing as when I subtracted this from 1. Why? Why would that work out the same? The area is equal because what's the shape of my curve?
A normal bell curve.
A normal bell curve, so I'm symmetric about the mean, right?
Yeah.
It's symmetric about the middle. If I folded it in half over where x is over the standard deviation of 0, smack in the middle, this area would be the same as this area. So a little shortcut is, if I ask you to find the area to the right of something, can't you look up the negative of it and give it to me from the left? Because your curve is symmetric. So say I did this. Say I asked you to find the area to the right of 2.0. You have 2 ways to do this. We could look up 2.0. Let's look it up both ways. Look up 2.0, and what do you get? 9,772. Thank you. That means this whole area is 9,772. Is that my area to the right of it? No. So to the right of it, I have to say 1 minus 0.9772. So I get 0.0118, hopefully. What's another way I could look up this area? Negative 2. Let's look up negative 2. Negative 2 should have the same exact space here because this is symmetric. So negative 2, now be careful because it goes all the way, oh, my mistake here, I subtracted wrong. Okay. Go all the way to the right because the negatives go down instead of up. So this little area is the same exact thing. Is it not? Because your curve is symmetric. Because it's symmetric and it adds up to 1, we're able to do this. Kind of like the probabilities. When you have a complement case, you say everything but that. You subtract it from 1. So we do the same exact thing with your curve. It's making a little bit of sense? Okay, this is really, really important that you get this part. Let's work another one here. All right. So we want to find an area that corresponds to a score of a z-score of negative 0.24. Between what two z-scores on the bottom of this graph will I find negative 0.24? Between 0 and 1? Between 0 and what? Negative 1. So it would probably be closer to the 0. This is negative 0.24. When I look this up, I get the area to the left. Should it be less than 50% or more than 50%? Less than 50%. So look up negative 0.24. No? Negative 0.24. No? 0.4052. Is that what you said? 0.4052. So I said it would be less than 50%. That's looking like it's close to 50%, right? But it's still less than 50%. Now, if I wanted the area to the right of this, what would I have to do? Subtract it from 1. And then that would be more than half of it, wouldn't it? So sometimes when I say to you, find me the area to the right of something, I want you to sketch. I want you to see. To the right of something, it has to be more than 50%. When you look up to the left of it, it's less than 50%. So that right away should say to you, I have to subtract it from 1. So it's almost like a no-brainer in this, if you use the sketch. If you look it up, and my answer, I said find the area to the right, and you get something less than 50%, you say to yourself, I got to subtract from 1. And the sketch is also going to help us get the negatives and the positives down pat. Because that's usually another issue with this. Okay? Okay, so now you guys are going to find me these two things. Make a sketch on your paper and locate the area to the left of negative 2.19 and then to the left of 2.17. Alright, so what did we get for the left of 2.19? Negative 2.19. Okay, everybody good with that? Way less than 50%, right? I expected it to be that. To the left of 2.17. Wait, say that again. 9850. And we expected that to be quite a big chunk, right? Quite a big chunk. Okay, now, I'm going to show you how to find this on your calculator without the table. You don't have to use your calculator for this. Additionally, over the years, I get half of my class using the calculator for this, half of them using the table. I happen to be a table person myself, but I'm going to show you on the calculator where to find this. So, go to second theirs, same place where you found your binomial PDF. But what word stands out right there? Normal curve, right? Isn't that our normal curve? And when we look for your information, aren't we accumulating this? So which one do you think we should use? We're accumulating our area from the left on your normal curve. So you're going to come down here. And this is how I want you to associate it. So this way when you're looking for it, you find it. I'm looking for my normal curve, and I'm accumulating my area from the left. So it says, I'm going to look up negative 2.19. I want this whole area in here. It says, give me a lower bound. This is my lower bound. This is my upper bound. Right? My lower bound automatically defaults, and they leave it as a default, -1 to the E99, so it gets to 0, 0, 0. You could also just do -99999, and it works all the time. Or you can just leave their default in there. The upper bound is this guy. Where do I want this to stop? Negative 2.19. Because we're on a normal curve and we want the z-score area, we're going to leave these. These are important. Your mean is 0. Your standard deviation is 1. Wasn't that the characteristics of our normal curve? Right? And we're just going to come down to paste. All this does is set this up for you. There's your area. We get 4 decimal places in your table. So if you round this to 4 decimal places, isn't it 0.0143? You're also going to find your calculator is far more accurate because it doesn't have to do any rounding. It burns it out. If when you're doing these things in an equation somewhere, or you're setting this up, you're going to see you get a closer answer with your calculator. Now, do you have to do it this way? Absolutely not. But this is a nice way to do it. So if we want to do the second one, we're going to go second varies to my normal curve that accumulates my area from the left. I'm coming from the left, and I'm going to stop at 2.17. I'm going to keep my normal curve characteristics and paste. And there's your 9850. See it? So you can use your table or you can use your calculator. It's a nice little feature on your calculator. All right, so now we're going to look at, and we looked at area to your right. We're going to look at area to your right now, and then we're going to look at area in between. This board, I can't complain because I actually have one. All right. So we talked about going to the left. So now, we're going to find 1.23. Between what two standard deviations on the x-axis does that fall between?
1 and 2.
1 and 2. Probably a little closer to 1. Now, we want your area to the left. Should it be more than 50% or less than 50%? More. So we're going to look this up in your table or in your normal CDF on your calculator. Let's use your table, and then I'll do the whole thing with your calculator with the right and the left. And then you'll see the difference. So let's use your table for this one. So if I look this up in your table, what do we get? 0.8947? 07, thank you. 0.8907. We said it would be a lot bigger than 50%, right? Now, if we want the area to the right of this, what do we have to do? Subtract it from 1, because that doesn't cover the whole curve, right? So this makes perfect sense that I'm going to subtract this from 1. So subtract it from 1, and then it'll tell you what you get. Okay, so we get point. So if I was looking at this problem, and they just gave me this problem, what's the area to the right of this number? I looked it up in my table, and I got that really big number. I said, that's not possible, because it's way less than half. So in my head, I say, okay, you must have to subtract it from 1. There's only 2 things you could do. Find it on the table, subtract it from 1. To the left, to the right. Okay? Well, actually 3 things, because we have an in-between. Now, second is, I want to find the area between this guy and negative 0.75. Between what two whole numbers on the bottom do I find negative 0.75? 0 and 1, probably a little closer to the negative 1, right? Now, just watch up here 1 second. Watch what happens when we do an in-between. I want the numbers, I want the area in between here, right? Don't I want the area in between there? If I look up 1.23, I get this whole area over here, right? This whole thing. If I look up negative 0.75, I get this area right here. So what do you think I have to do to get that middle section? Subtract it. Not subtract your z-scores, we're going to subtract your areas. Technically, if I punch this guy out of here, if I subtract it out of here, I'll be left with what's in the middle. So we already know this guy. We just have to find what's the area to the left of negative 0.75. So look at your table. Find the area to the left of negative 0.75. And what do you get? Okay? And then we subtract those. So this comes out to be 0.6641. Now, do you remember what your plus or minus 1 standard deviation was from your empirical rule?
68.
68%. Good. So kind of work with me a little bit here. I'm a little bit over the negative 1. I'm a little bit over the positive 1. So if I kind of just shifted back a little bit, and I look between 1 and negative 1, I'd expect my answer to come real close to 68%, right? Logically, does my answer come close to 68%? So I know I'm on track. There's a lot of different ways for you to figure out, is this feasible? Is this right? Because we have so many nice characteristics about your normal curve and your standard normal curve. Now, in your calculator, for those of you that like the calculator, again, normal CDF. It's a normal curve, and we're accumulating from the left. If you want to do this one for your 1.23, leave your left boundary, set that. This goes at 1.23. Leave these in place and paste. And we get, as we round, 0.8907. See it? Okay, now, I'm going to do it again. I want to find the other one. The other one was negative 0.75. No, what was the one over here? Positive 1.23. I want to go to the right of this. So watch what's going to happen. If I want the right of this, where's my lower boundary? 0.123. 1.23. 1.23. My upper boundary is way. So make it 999. I'll never hit 999. 0, 1, and paste. This will automatically do your area to the right. See it? It's a little bit more exact than finding it in your book, on your table. Now, to do an in-between, the in-between is the best. If I'm in between these two scores, there's my lower bound, there's my upper bound. So my lower bound is negative 0.75. My upper bound is 1.23. I'm on my standard normal curve. I paste. Isn't that what we found when we subtracted both of those? Here's your 6640. When we subtracted the two areas, the in-between, if for nothing else, do the in-between on the calculator. It's the best, because then you don't have to think of negative 999, positive 999. It is your lower bound and your upper bound. So is this kind of making sense to you? Okay? I think we can do the left. I'm going to give you guys an in-between to do. Let me get rid of this mess over here. So, for this guy, just do this one. Do an in-between one, sketch it, and either use your calculator or use your table to find out the area. The one thing you don't want to do is subtract your z-scores. You always have to subtract your areas, not your z-scores. I'm coming, guys.